Good day everyone. Today we are going to solve a problem from Striver SD sheet, that is the minimum platform required for all trains to reach a railway station. Okay, we are given the starting time and end time of every train respectively. Okay, so we have to find the maximum platforms needed. No, we have to find minimum platform needed so that maximum trains come at one platform, then only we will occupying second. If one is empty we won't, and we are given condition that at the same time two trains can not be at the same place. Okay, obviously at same instant of time two trains can't be at a platform, so that start time and end time of another train can't be at the same time. Okay, so let's start this problem. So if you have gone through my previous lecture, so there we solve problem. Maximum meetings can be fixed in a one room. So if using that logic, we can create an array of arrays, that is departure, arrival, and sort that out. Okay, at one time the maximum trains that can arrive at one platform, we will be creating a function that will be doing this thing and returning arrays containing those time or that meetings have not been performed, that is the trains that have not been allotted any platform, and we will be calling that function again and again until unless that function returns null to us, that is all the trains have been exhausted somehow. Okay, but that would be complexity be going to O of n square, and keeping this in mind it would go to 10 to power 9. Yeah, it would go 1 2 3 4. Yeah, it would go to 10 to power 9. So let's solve in another approach. So now what we can do is we can sort the arrays first. Arrival dot sort and departure dot sort. Idea is very simple. If a train so we will be creating like um two counters. One would be the maximum platforms occupied till time. Okay, max plat, okay, occupied till now is 0, and currently how many uh, are how many platforms have been occupied, that would be another. Okay, initially we can consider it as one, like one train is standing. Okay, consider for first one the time started at 9, so one station, like one platform is already occupied and train is standing. From now, from here we have to work. Okay, so what we are going to do, if a train leaves, the current platform value would reduce, but if a train arrives before the leaving of the first train, we have to go to the next platform, so we'll be increasing the value of current platform, and the maximum number of platforms at the current time we have uh, seen, that we will be updating to max platform. Okay, very simple. Let's start. So for I in range of start, okay, arrival index comma departure index. Arrival index would be 1 and 0, as first train we have already considered. Okay, while arrival index, that is all the trains have arrived, we don't care when they will be departing if all the trains have already arrived. Okay, arrival index is less than n. Okay, now what we have to, if arrival index, that is means if a train has arrived before the previous train left. Okay, departure of departure index. So what we have to do? So there's a problem, so just increase. We are assigning new platform plus equal to 1. Okay. Elif, suppose new train arrived, or you can say train departed before arrival of new train. Okay, here we can consider that case also, where at the same time there is one train is coming and one is already standing, so again we have to assign one new platform at the same time if two trains are there. Okay, so if this is the case, that is if a train departed before arrival of the new train, what we can do? Current could be reduced. Current platform value would be minus equal to 1. Okay, throughout this we can consider it 1 also. Okay, now in this case only we have to see if max, okay, max plat is less than current platform, then just increase the value. We could even have increased, but that would, if we would have increased by 1, that would have worked also, but let's swap the value, like assign this value, right? And at last what we have to do, we have to return the maximum platforms we have seen till now. Okay, in these cases one more thing we have to do, that is in this case. Okay, so what we are saying, if a train arrived before departure of another train, okay, that train is assigned a platform, that means that train is come, so next time we'll be going to the next train, right? Arrival index plus equal to 1. Now in this case, if a train has sorry, in this case, if a train has departed before arrival of new train, if it is departed, so you can go to the next train for departure time. Okay, let's try to run this problem. Program took more time than expected. Okay, complexity is often. Okay, arrival index value is increasing, but in case hmm, hmm, what we can do over here is, let's try to dry run this then. So what we have done is, if a train first, let's try to do custom. Moreover, Let's try to print the values we are getting, right? So departure plus equal to 1. Okay. 2342. Expected output is 2. Okay. Okay, it's working. I just forgot to update this value, right? Let's try to submit. Okay, it worked fine for all the cases. Thank you.